My name is Felix Geisendörfer, and I'm going to talk about how to do testing in Node.js. If you're looking for me on GitHub, Twitter, or IRC, that's my handle. Yeah, Tom already gave a little introduction about me, but I guess I've been an early contributor to the project, and I kind of worked on a bunch of modules. And I actually really liked that Matt had the talk right in front of me, because a lot of the problems he's describing that he has with running Node in production have different solutions in debugging. Linus Torvald recently, I don't know how recent, but wrote on a mailing list, there really are only two acceptable models of development: think and analyze, or years and years of testing on thousands of machines. Now, for most software, you're going to need a certain combination of the two. You're going to need to do a lot of thinking and analyzing, and a lot of testing on a lot of machines. But I think the think and analyze part can be greatly enhanced through certain techniques when it comes to testing Node.js applications. And they can save you a lot of time on the debugging part and the running on thousands of machines. So let me tell you a little story, how I was using Node before I learned my lessons and how we're using it now. It kind of started in June 2009. We were building a product called Transloaded, which is a service for file uploading and processing as an infrastructure service. It's kind of similar to what Matthew talked about at Yammer. They're actually using the Node Formidable file upload parser for that we wrote. And we initially did that in PHP. And we tried to do a lot of things that were difficult in PHP, like running a lot of processes in the background and getting events for their standard out and standard error to show encoding progress information to the users. And it always felt very tedious. We were using workers, we were using queues, and we just got nowhere with that. We didn't get the results out of that we wanted. It was certainly doable, but it felt painful. So we found Node.js, Node.js TM, and we kind of fell in love with it. And we had a lot of fun using it. It really solved our problems, and we were thinking, yeah, that's the answer to all of our problems. But actually, our first version, we totally crashed it. It did not work at all for us. To be more precise, Node crashed for us. We were on a very early version. I think it was 0.1.18 or something, and it had a buggy piece in the networking layer, and every so often our server would just die without throwing an exception, just this little message you see here, fcom receive success. Wow, awesome, success, and then a segfault, but without the segfault part. So we were really close to launching at that point, so we were like, oh no. And well, as these things happen, when stuff hits the fan, there's more coming. And this was exactly the time where Ryan was changing the Promise API and nuking it completely from the core and putting in callbacks instead. And we were like, oh no, now we have to rewrite all of our code, on top of the fact that our initial code base didn't even work to begin with. But an even bigger problem was we had no tests. We had written like 10,000 lines of Node.js code, and now refactoring every single piece of the code that uses a promise to a callback, I mean, it was not going to happen. So we devised the greatest plan of all software development ever. We decided to rewrite the whole thing. That's what a software engineer does, right? No, we really kind of went back and forth if it made sense or not. But we decided that not having a test suite was actually a really big problem, even a bigger problem than the fact that promises were changing underneath us. And at that time, I was watching a RailsConf 2009 keynote by Robert Martin, also known as Uncle Bob, and he gave a presentation called "What Killed Smalltalk Could Kill Ruby Too." And it was a really energetic presentation about test-driven development, and I got all pumped up and excited. I even ordered one of the little green wristbands he has for people to look at and be constantly reminded to write the tests first. And I was very excited. It's kind of me in the background there, being very excited. And so that's kind of how I got into that. It's been a year that I've been doing test-driven development, so take what I have to say with a grain of salt. I'll talk what works for us, what doesn't. And yeah, let's get started with this. How to test asynchronous code. When we decided we want to do this test-driven development thing, we want to be really disciplined and do it all right, we kind of looked around for asynchronous testing frameworks. And but it kind of felt hard. Everything we tried didn't really work. The flying closure monster didn't really help. You already have those closures in your code everywhere, and now you also have them in your tests, and you kind of need to make sure that each test kind of has a done callback where you tell it it's over. And if there's an exception that you didn't catch, it's really difficult to trace it back to the test that it was happening in. It was just a mess. It didn't really work for us. It turns out this is not a new problem or anything. This problem has been around for a very long time. The asynchronous stuff is only a piece of it. But there's some old news here. And that's why I brought this last week's newspaper. It's a German terrible tabloid magazine. And there's a little demonstration we can do with this. What I'm going to do is I'm going to fold this thing 7 times. Guess that's 2 right now. 3, 4, 5, 6. Gets tricky here. 7. OK, there's a lot of geeks in the room. How many pieces of paper are stacked up here now? Anybody? 128? Who said 128? Can you come here for a second? I could need your help on something. All right, come up. Yeah, folding it again would probably be hard, but I want you to try to rip it instead.
Rip it?
Yeah, can you rip it?
Oh, hell no.
OK, there's no way to rip it, right?
No way. No,
OK,
no.
OK, thanks. That's
Yeah.
all you had to do. Thank you. So what's the problem here? Well, the problem is that you can think of this newspaper as a metaphor for something else. You can think of it as a simple computer program that manages 7 Boolean variables. So you have the 7-bit thing that can add up to 128 states. And each Boolean in this program has an impact on the behavior of the software. In this case, it makes the newspaper sicker. And as a result of that, it is really difficult to rip through it as once. And it's kind of the same as if you try to rip through a complex program with a single test. That's the whole premise of this asynchronous testing. You're kind of doing end-to-end testing once you're doing I/O. And that is not a good way for testing. It has certain benefits, but it's certainly not a solution to everything. Why is that the case? The problem is the more variables that you get, in this case, let's say Booleans, the more possible states your software can be in. With the Booleans, you get an exponential increase in complexity of your software. And each of these possible combination of states could affect the flow of your program and increases the size or amount of tests you would need to write from an integration perspective exponentially. So that's obviously not going to happen. But what's even worse, you don't have Booleans. You have strings. You have JSON objects, which are really complicated because they're nested, and they have different data structures in them, array, dates, whatnot. So you don't actually end up with an exponential explosion. You end up with a combinatoric one. And if you're a math geek, you know that's one of those curves that you kind of run straight into. There's no way to write enough tests for even a simple program. You'll need millions of tests. So how to test asynchronous code? The answer is not really difficult. It's really an old answer. And the answer is make it synchronous. I'll get to what that means in a second. But we did it at Transloaded, and we released version 2, which was a lot nicer, kind of like you see in the picture with the unicorn. Well, almost. We have still problems, but it's much, much better than it was before. We now have processed many terabytes of data. We have a really low bug rate. I think the amount of bugs we had in production that affected users is less than 10, and of those 10, maybe 8 have been bugs where we wrote a test that actually specified the wrong behavior. There's not much you can do. And it's a pretty clean code base. There's things we want to refactor, but we have close to 99% test coverage. So how does that happen? Or how do you microtest code? Well, what I meant when I was saying you need to make the code testing synchronous was what I really was saying is you have to unit test. Unit testing means no I/O takes place. You have to inject all the stuff that would perform I/O. You have to inject test doubles for that. And that way, you never have this callback hell, because everything you're going to call is going to be synchronous. And if not, well, you need to do more stopping and mocking. So how can you do that? Well, rule number 1, as I said, no I/O. That's how you get there. You start out, when you load your modules, you make sure that nothing ever does I/O in your tests. Rule number 2, that's optional, depending on what you want to test, how you want to do it. But test-driven development really, really helps. Write the test first if you can. If you have a piece of software that you need to get in later on, you can always add a test for that later, but TDD is much preferable. And the last part is discipline. I will not kid anybody. writing tests for every single line of your code, it's a fucking pain in the ass. It is. I mean, anybody who tells you it kind of gets easier with time and it becomes really fun, it hasn't really turned that way for me. I mean, you see the results and you like what you get there, so you keep doing it. But it's really a hurdle to do a big project from scratch and write tests for everything. But I think the benefits of it kind of outweighs the disadvantages. So there's still one problem. What libraries do you use? What libraries do you guys use for testing right now? Anybody using BAOS? Anybody doing like real unit testing without I/O with it? Okay, few people. Other test libraries that are popular, Expresso maybe? Few people on Expresso. Maybe more general. Who's testing at all? Who's happy with their testing? A few people. I need to talk to you guys later on to see what you guys are doing. My plan for today was to release 3 completely new libraries, and I pretty much managed it. The fact that my computer was broken the week before I came here and jet lag and partying didn't help, but I'm pretty close to it, and they're already in a state where they can be played with. The first library is called Node.fake, and what it does is it's basically a simple mocking and stubbing library, but it doesn't force you into the concepts where you really have to think about defining all the methods of your mock objects beforehand. You can simply say, I have an object here, I expect the method call on that object with this signature, and then please verify this is happening in my test. And on the other hand, you can also do the kind of stubbing approach where you just inject a value, but you don't care, return value, but you don't care if the function is ever executed. Or you can as well verify state after the fact. So you can kind of go for the mockest approach of testing behavior, or you can go for the state assertion approach. And to wrap this thing up, I wrote another library called Node Microtest, which I will try to live demo here, but you guys know how that always goes. Something goes wrong, but you'll get a good laugh. And what this library does, it kind of helps with the discipline part of performing no I/O in your tests. Because what it does, it loads your test files in a separate V8 context. So the global object is completely free of any Node libraries. You don't have a require call. You don't have a process object. You have nothing in there. I do inject a few things that are just a little convenient, but you have no way to get I/O done in there unless you kind of hack around the system, which you shouldn't do. Maybe there's valid use cases. What it also has, it has Node.fake as a mix-in. So the methods I was talking about in the fake library, you get on the same class object. And I also have a very basic test describe framework in there that gives your testing a little structure. I might separate that out because everybody's kind of crazy about how they want their color-coded output to look and all that stuff that I didn't care about when writing this library. But it seems in the Node community, like colors are the coolest thing in the terminal. I won't argue that they're cool, but there's other problems to solve first here. And so the live coding will start in a second. And the third library, this one's actually working well, and I think the documentation is also complete. It's called nodefar, and it's basically find and run. So you give it a directory of files, of test files. It will find them all and execute them in its own node process and kind of give you really useful real-time output, show you how long the suit is running. It prints it all on one line. It will only show you output of your individual tests if one of them failing. You can kind of set the verbosity on that, and that's the third library. So let's try to do some bad live coding. So I was trying to find a really simple program that we could test here without running out of time. And there's this really cool new thing that's stabilizing a node now called stream.pipe. Who has played with the stream pipe stuff? OK, cool. And so what we're going to do, we're going to write a little cat program, which basically takes one argument, which is another file, and then opens a file create read stream on that, and then does readstream.pipe, and then process.standard out. So that's like a few lines of code, and we can easily test drive that. So since we're doing test-driven development, the first thing we're going to add is a test file. So we're going to name that test-cat. And we're going to use the Microtest library. We're going to say test equals require Microtest module, and then we're going to tell it where the module is that we're loading. One of the cool things at this point is the way this library works is it can load any JavaScript file. So I'm pretty confident that I can flesh this out later on to actually test browser scripts as well, because you get a new V8 context, you can pre-fill the global object in that, so it's pretty easy to do the same kind of testing with the same library. And another thing that's good is since you're unit testing here, you don't actually care about the browser behavior. So the fact that this will probably be limited to running a node is exactly what you want here. If you want to do browser tests and use Selenium or something more higher level. So we should already have a failing test here, because I haven't created the cat.js file. So yeah, right here it says file not found. So yeah, that's readable. So the first thing we need to do for test-driven development is make a test fail. We did that. And now we have to make it pass by creating a cat file. So close this little window. So when we execute the test now, it's passing. So it's verifying our test is there. The next thing we want to do is we probably want to include the FS module, because we're going to need that for the read stream. So we're going to say our test requires the FS module. And to make this test fail, we have to do one more step. We're going to have to say our cat module is created by compiling this test. And what this will do, it will actually load the source code, run it in a new V8 context, and give you the module exports back. And like creating this module.exports object and injecting that, that's as far as I go in terms of mirroring the Node API. A few other things like underscore file name and dir name, but not much fluff beyond that. So if we execute that, it's going to tell us it's calling off the screen. I'll have to switch to terminal for that. Okay, I guess that needs bigger. Okay. Module test kit has no method require. Oh, requires is the function name here. That's why it didn't work. So what it now says, it gives us expectation that has failed. It says, I was expecting a different call. I was expecting require fs to be called in your file, but instead module.verify was called, which is called when you call compile, it verifies that all expectations that have been set up until that point are met. And so it's telling us what to do. Includes this require fs module. So that's what we're going to do. We're going to go back to our cat.js file. We're going to say var fs equals require fs. And that should make the test happy. OK. So the next thing we want to do is we want to assert that on the FS object we call create read stream. So what we're going to do is we're going to say test expect, and then the reference to this module is actually on the test object in a property called required. So it's test.required.fs, and we're going to say create read stream. OK. Now if we execute that, OK. Let me do that over here. OK, so again, we get the failing assertion here. It was expecting fs.createReadStream to be called. It's not being called, so let's fix that. OK. Now the test is passing again. So what do we want to do next? The next thing we probably want to assert is that this create read stream call returns our injected read stream, which is not the real one. And then we want to make sure that the pipe method is being called on that. So what we'll do is we're going to say, we're probably going to name this variable file. And I use all uppercase for my test variables, just to differentiate the stuff I'm asserting against from the other stuff. It's a less annoying form of duplication than adding like a prefix or suffix to them. And it really helps because sometimes you actually also get variables out of the test and you use those with underscore and they have the same parameter signatures. So what we're going to do here, actually the underlying fake library includes a little semantic sugar that lets you create a test object. What this really is just an object, and if it fails in some assertion, it's going to give you this name again. And so you have a very clear idea of this is a test variable, and since you say object, you probably care about the reference to it. You don't care about the value. So what we need to do now is we need to return that file object here. So we can do and return the file. Ooh, wow, that's crazy. Let's not do that again. So what this will do, it would return the file. This should not fail the test yet. Yep, it doesn't, because we're not really doing anything with the file object yet. At this point, it might also be worth knowing that there's shortcuts, because you're going to write this stuff a lot. So what you could have also done at this point is to put that in a third parameter in an array of all the arguments it's expecting. That's kind of a semantic shortcut for that, but we'll go for readability here. So what we now want to do is we want to expect the pipe call. So we're going to say test expect file pipe. Okay. Let me do that in the other window again. So yeah, it's saying I was expecting a different call. I was expecting pipe, but it didn't happen. So let's fix it. Okay, we're not really sure where to pipe yet, so let's not do that. That makes the test pass for once. And now what we want to do is we want to pipe to process standard output. So what we need to do is we kind of need to create our own fake process object. This time I'm actually going to just use a plain literal because it's a little easier for what we're doing here. What we want to do is we want to have a test object called process standard out on this. And we need to tell our test to use this object. So another way to inject that is we can actually inject into the global object of our sandbox. So we're going to do test context dot process equals process. And now we can ask that our parameter to pipe is actually process standard out. I'm using the long form here again with args and process standard out. Okay, now it says unexpected argument count. It was expecting one argument as a pipe function, it got 0. What's also kind of nice is it tells us where the expectation was set up. It tells us in our test case it was line 18, so that kind of makes it really fast to jump back to where you need to fix things. And now we're going to do process standard out. Oops. Oh, this didn't work. I need to uppercase that. Sorry. OK, if we run that, the test passes again. So that's pretty much almost the whole cat program. The only thing we didn't implement was telling what file to actually open on the read stream. What we really want to do is we want process argv2, because that's where Node has the first parameter we pass into it. So let's do that real quick. We need to create a fake argv object here. The first two parameters don't matter, so we're going to make them null. And yeah, for the third one, we're just going to say file.js or something. So we go back to the read stream test. We add a with args expectation here, process argv2. Yeah, we get the exception again. We go back into that. We're going to fix the test. OK. Looks like it ran. Anybody see a mistake so far? Or do you guys think we can try running this? All right, let's try running this. Let's try to output our cat program. OK, that worked. So we just test drove that whole thing. I think I'm running out of time shortly, so I'll skip ahead to the other slides. There's a lot of stuff in the API. There's a lot of ways you can verify this behavior. It has excellent support for also setting expectations against classes being called with a new operator, injecting your own stuff there. There's lots of stuff in there. Let me try to find my remaining slides. Yeah, so one thing you're probably asking, well, this kind of looks like a lot of code for very little behavior. Well, that's the case. And I'm not going to lie. But let's look at what that actually means. At Transloaded, so we have around 6,000 lines of code of library stuff. There's a lot more dependencies, a lot of stuff we wrote. But we kind of have a lot of test code for that. We have 12,000 lines of code just testing the behavior. We have a lot of fixture data, server configuration, the customer websites, and dependencies, but those are not included in this amount of test data. What's really interesting here is to first see that measure 1 to 2. I think that's too high. We went a little crazy there. But I think 1 to 1 is what you're going to get if you're going to do it seriously, probably a little higher. What's also worth knowing is the distribution between microtests and integration tests. So unit tests that I was showing how to do, we write a lot of those. And those are actually, we've written huge amounts of our programs just that way. And then we write one integration test and it kind of works the first time. It's beautiful to see thousands of lines of code coming together like that. And so the factor we have here is 1 to 4. And we have more integration tests on Transloaded than I would like for other stuff because we need to do crazy stuff with FFmpeg. We need to extract thumbnails from the videos we encode and then do visual verification against a set of fixture data to see if it still works. FFmpeg is one of the most broken open source projects ever. I mean, it's not broken, but it has a very strange way to interact with the community and the people using it. I'm very grateful for their work, but Node is such a nice community to work with. But what becomes even more clear here is when you look at not the amount of code, but the amount of assertions. So that already looks pretty good. We probably have too much duplication in our integration tests. That's what it means. We have, I don't know, 190 asserts on the integration tests and 2,300 on the microtests. And just a reference point for something else, for library code, Node MySQL has a factor of 1 to 1.35. For library versus test code. I think that's much more reasonable, and I hope to get that even further down to 1 to 1 with that new microtesting I was just showing. It has a similar integration versus microtesting here, and it's also doing pretty well when you look at the assertions. So to finish this up, yes, this is a lot of code, and it kind of feels like it slows you down. But one really good quote on the subject is, why do you have brakes in a car? They're not there to go slower. They're actually there to go faster because you can speed up to a curve and hit the brake and slim around it. And that's what we really see with this. It costs a little bit more time to develop new features. But if we hunt bugs in production, like the one Matt is hunting, we can actually test a lot of things on a very low level. Like, what happens if an error event is being emitted here? Are we handling that? And we are able to usually pinpoint sources of error very quickly, write a test for it on the micro level, sometimes also on the integration level, depending on how easy it is to get to this pass. And then we sometimes throw the integration test that shows the bug away, because the microtest is defining the behavior of our program. So the too long didn't read. Don't use integration tests to show the basic correctness of your software, and write more microtests. I don't know if I have time for questions.
We can do one question while we're setting up, or 1 or 2 questions. So if you have questions, ask them quickly. Questions? Anybody?
This whole idea of microtests sends me down the dependency injection sort of factory pattern
Yes.
approach. Is there a framework or a package or anything that you use for DI?
Yes, basically you don't need to do dependency injection because you can inject a reference to the class that's being required. You require another class, you can inject your own constructor for that, and then you can actually say test.expect, the reference to your test double constructor, and so you don't need to change your code to test it. That was one of my design goals for this. Don't write your code for tests. Write it for your human readability, and then figure out a way to test it.
Great. That's it. Thank you.
Okay. Thank you. Sorry for going over time.